My name is Lee Avital, and this will be a talk on half functional programming and half on type systems. And we'll do that all in the frame of Scala, which is not um, a completely functional programming language, but is enough to talk about it and get a sense of the ideas. So, the main problems with non-functional programming languages is you, or I shouldn't say with non-functional. The problem with all programming languages, and with some more than others, is that you can type down a program and your program will compile or be interpreted by the interpreter, and it won't actually be correct. So you can write a Python program that can be run, but it might not do the correct thing. And you can do that very easily. With Java or C++, you can also write a program that doesn't do what you want it to do, but will compile and give you a valid executable. I would argue that it's a little bit harder to do that in Java than it is in Python, but some people might disagree. So we have all of these things that in scripting languages we've done to get a greater degree of safety. So in JavaScript and PHP and maybe Python and Ruby, I'm not sure. We have a notion of a strict mode where certain unsafe things are discouraged. For example, in JavaScript, you can't introduce variables into the global scope if you use strict. We have type hints, which allow you to optionally annotate types, and that's showing up that's been in PHP for a while. That's probably going to show up in Python in the next big release. I don't know about Ruby or JavaScript. We also have static analysis, which is a relatively new thing. Facebook just released some tool, I forgot the name, but it will look at JavaScript and try and make sure it's correct. And then on the other hand, we have in these compiled languages classes and generics. So you started out with the C type system, which is very hard to work with because you have all these void pointers flying around, and you need to cast things to be certain types, and sometimes those casts aren't correct. So we have these two mechanisms to make programs easier to write correctly. Like I said, this will be framed in the context of Scala, so I would recommend that you install Scala if you want to follow along. So, how does functional programming solve problems? For one thing, it's a lot more expressive. So, I have two little snippets that do the same thing. One is 3 lines, and one is 1 line. So this for loop is a very common thing that you write in any iterative language, where you're going from a list of one data type, and you want to go to a list of another data type where both of the lists are the same length, and you're applying a transformation to it. So, fancy word coming up, we've reified control flow so that we can do this kind of process generically and easily in 1 line. And we'll see a couple of examples of different iterative patterns that turn into functions. The other thing is another fancy word called referential transparency, and I might have spelled that wrong. Referential transparency means no side, like exactly what it says, no side effects, and this is a very contrived example of why side effects are bad. So can you imagine if you ran this in a Python program? So the function is called length. It does return the length of whatever argument is being passed in, but for some reason you're redefining false to be true. And that is going to mess up the whole world that your program is running in, right? Because every time you type true, you now have to type false. So while that's not, that's obviously never going to happen, no one in their right mind would do that, these kind of side effects can be very hard to find and make things very hard to debug. So those are the two big reasons I think that functional programming is good to support correctness of programs. But I think that the more important thing for program correctness is types. So here are 2 examples in Java that point out why we need a good type system. So in the first example, we have a string being initialized to null, and then we're going to print this string. The toString is technically unnecessary, oh, no, it's not unnecessary, but because it would just print, we all know Java. Maybe we don't. I don't know. The toString, when you try and call toString on null, what happens? Sure, it'll explode with a null pointer exception. In our type system, we want to be able to say that null is not allowed because while it's very clear here, we might declare null somewhere and then do a bunch of work and then print s in the hopes that we set s, but maybe we didn't. And then the other one is if you've ever programmed in Java Swing, which I think all of us are either software engineers or CS majors, and so we all have. You have to do a lot of this casting, and casting is inherently unsafe because you're saying, I can't prove this. I can't prove that this type is what it is, so I'm going to force it. It's kind of like just saying, okay, compiler, trust me, I know what I'm doing, which we really don't. And then the other thing is, and this is what I think is really important about Scala, because creating types are cheap, is that primitives are not at all descriptive. So string is just a terrible type because it doesn't say anything. I can say that a name is Lee and a color is red, but I wouldn't in any real situation ever want to compare that unless I was treating them both as strings. But no, they're different data types, their names and their colors. So here's the equivalent Scala where I have a very lightweight class that I can actually erase at compile time. So I have one called name and I have one called color. And if I say name equals color, it won't compile because they're not the same type. Because in no world would you want to compare a name and a color and see if they were the same. I mean, you can extract those strings in Scala, but it's very difficult. So why did I choose Scala for this talk and not the more obvious Haskell? Haskell is, for those of you that don't know, Haskell is the quintessential modern functional programming language that everyone frames these sorts of talks in. But I think Scala is a little bit more applicable to our everyday lives. It's fairly in demand in industry. It's compiles to the JVM. Notice that I'm throwing an exception here. Now, if I were to write this down in Java, if I were to verbatim translate this program into Java, I would have to catch an exception somewhere. Probably around here, right? Because Java knows that this method might throw an exception, so I need to do something about it. But in Scala, exceptions are not managed, none of them. And we'll see how Scala manages this in the next few examples. So I get my person, I instantiate it, and then I call this print function. And sorry about jumping around. Like 70% of this code will be the same throughout all the examples. I print it, and then I'm done. So let's run this. So I use my handy Scala compiler, and it's very slow. And then I run. So notice all of these classes. So just like Java, the unit of compilation is a class file. So I'll run my main. I'll enter my name. It's Lee. I'll enter my age, and I'll enter my favorite color. So it prints out. Can you guys see that? Good. Okay. So it prints out my name and my age and my favorite color. So that's great, right? That seems like a little much for that simple program because you could just, this is like 3 lines of Python, 4 lines, not even. But let's look at what happens when I make a mistake. So my name is Lee, my age is red, and oh no, look at what happened. So what happened there? I tried to call integer.parseInt, or was it the other way around? Yes, I tried to call integer.parseInt on red. Java says, oh, that's not a number. I guess I'll just throw an exception to the next method and hopefully someone will catch it, right? Not right. So let's look at how to handle this in Scala. So I have the same, I have what looks like the same, and then I have this craziness. So let's look at the toAge class, shall we? So I've got this toAge, and notice that I've changed the type signature to option of int. Now, what I'm doing here is I'm trying to parse the integer, and if I do, I'm going to return some int, and if not, I'm going to return none. So this type forces you to make a choice, because you're either returning something or nothing, and the option aspect of it encapsulates this choice that we have to make. So this is kind of this mimics the pattern in Java, or really any language that is imperative, where you say, okay, if my method doesn't know what to do, I'll return null, and I'll leave it for the caller to check for null. And this, if you've ever worked on a large Java code base, which I did this summer, and it almost ended badly, if you forget to check for null, you have a problem, right? Because now you have null pointer exceptions, and you could pass it, you don't know how long throughout the call chain you could pass it until it becomes null. So we use this type option, which is actually going to be part of the Java standard library soon, to force us to make a choice about what to do. And then we're going to do the same with color, and it looks the same. So if S is red, I'm going to return red. If S is green, green, blue, blue. Otherwise, nothing. So now I'll go back up to my main function, whatever you want to call it. By the way, if any, I'm kind of just glossing over syntax right now because it's kind of, I don't want to get caught in the minutia, but if anyone has a question about what a particular line is doing, feel free to pipe up and ask. Right, so now I'm calling my getLine, toAge, and toColor functions, right? And this looks almost exactly the same. But let's see what happens when I uncomment this line, which is exactly what we had before. And I already have the answer here, but I'll just show you what happens. Right, see, we can't construct a person like this because age is not an integer. Age is possibly an integer, possibly nothing. So this introduces some funky Scala syntax. So we're going to do what's called pattern matching on the color. And so this syntax basically says, okay, take color if it's sum, and I'm going to bind my new color into that variable called color. Do this thing, otherwise do this thing. And this whole thing is an expression. So I'll show you how that works in a minute. We'll do the same with age. And so if we do both of these branches, we'll get to this print person. And now we have name and age bound to actual variable, the actual types that we want. So we can print this, right? Now, one nifty thing is I said it forces you to use that, to make that choice of nothing or something. So if I comment this out, what do you think is going to happen? Anyone? Okay. So, sorry. Well, let's see. So it will compile slowly. Yeah, but it will give you a warning because you're neglecting to make this choice. So this is one way that the type system forces you to be safe. So let me uncomment this. All right. And then, okay, we'll compile this again. People don't care about the speed of the compiler. It's awful. I really wish they did. So it's, yes.
Is there some variety of unwrap method that is like give me the internal value of the option or throw?
There is. So here, let's make use of this read-eval print loop, or REPL as it's called in the parlance. Can everyone see this, or should I do some resizing to? This is fine. Okay, so I'm going to say my E is sum red, right? Okay, so I can say, yeah, I know, guys. So I can say e.get. So that's fine. I just unwrap it, and that's fine because that's the valid code path. Let's say val e2 equals none. And what do you think is going to happen? Explodes. Yes, exactly. We also have get or else. And, that's pretty easy. Right, but there are actually even nicer ways than get or else. And we'll explore those in a minute. So I recompiled my 2.scala, which we're using the options. And my name is Lee. My age is 21. My color is red. Okay, so that's fine. Let me see what happens when I mess up. Ah, interesting. It didn't explode. All right, and now I have error, bad color, right? So let's take a look in this match thing. So does anyone spot maybe not a problem, but kind of something that's undesirable about this little snippet of code? There are a few things, yes. That's one thing, yeah. So one thing that strikes me about this is that it's very deeply nested. So you can see how the nesting grows linearly if we add more and more inputs. So if I added, say, my favorite sandwich topping, we would have another we would have another level of nesting, and that's undesirable, right? Because editors are narrow. If I want to give talks like these, we want it all to fit on that side of the code. The other thing is that the error messages are coming from the caller of the function. So every time I call toColor, where's that? Every time I call toColor, I need to know that if I'm getting none, that the error is that the color is bad, which is obvious in this case, but not always. Have you ever been in the situation where a function returns null, and you're like, okay, but what does that mean? I don't know where the error is coming from. Yes, so let's look at this next one. So first we're going to take care of the nesting. So I'm actually not going to look at this file right now. So before I go into that, let's jump back into the REPL, and let's think about option types as lists. So in Scala, I can construct a list like this. Give it a second. Give it a second. Give it a second. There we go. List 1, 2, 3, 4. And then I can map a function to it. This is similar to a Ruby map or a JavaScript map or fairly standard map. And I've just added 2 to all of the languages, all of the numbers. So that's pretty easy, right? Now, I can also think of I can think of option types as lists of length 1. So I can do sum1 map, and then I'll turn that into a string. Whoa, no, I won't. Oh, right, okay. Right. So now I have an optional of sum.string. That wasn't very clear. I'm sorry. I'll add 2 again. Okay. Oh, it's not derp. All right. Okay. Yes. All right. So my sum1 is a list of length 1, and my none is a list of length 0. So if I map that, value plus, right? Okay. So this doesn't know what the type parameter of none is, so I have to specify integer. So I should mention that Scala is semi-type inferenced to the point where you might have noticed that there were some places where I was annotating types and there were other places where I weren't. The type inference algorithm Scala uses is not as sophisticated as, is not the most sophisticated, but it's pretty good. So most of the time you can get away with not annotating little things. Anyway, so I have my E, which is none, and we're considering it a length of 0, and then I can map that. And it's still none, right? So I can, we're on 3, right? Yeah. So now I can use these functions called map and flat map, which I'll talk about in a second, to kind of decrease the level of nesting. So we haven't gotten rid of the nesting completely, but we have gotten it down by 1. So to see why I'm using flat map, let's look at what happens when I get an option to an option. So does anyone have any idea what the type of this what the type of this will be? What? It'll be sum inside of sum. Right, that is what it will be, but what will the type be? No. So I was looking for option of int, but yeah, basically. Right. So yeah, exactly. So that the same thing would happen there. So what we can do is we can use this operator called flatten. So if I have a list of lists, right, I can flatten them, and I'll just get that list. So too can I do that for options. And I can say flat map some x, and now I just get the last option. So the option propagates down, which is pretty cool. So doing that, I can make use of some sugar, some syntactic sugar, and I can use this for loop, and then automatically this will be translated into a series of maps and flat maps. So let's just look at this for a second because it's kind of hairy. So the first thing I do is I get my line. Now I have to wrap this in an option because I know that it's because of the way that the for loop works. So this becomes get line dot map with my name as the next parameter, and then I need to do this underscore equals because I'm throwing away the value inside the for loop. A lot of this is because of the syntactic limitations of how you can write this down. And then I can say, do the same thing for age, enter the color, figure out what the color is, and then this yield is allowing all of those options to propagate into one option. And then I'm putting the output in there. So is that kind of, does anyone have any questions about that? Because that's a little, it's a little hard to see how that is the same, how that is exactly the same as this. No? Okay. All right, cool. Cool, so let me compile this just to prove that it works. It does. Yeah. I know. It does improve for like larger projects. So like if you have a 10-line file, it won't take 10 lines as long. So I can enter my name, I can enter my age, I can enter my favorite color. Right? Cool. So one thing that has changed here is that I'm not getting all of my options at once, right? So I wait for the name to come in and be successful, and then I get an age, and then I wait for my age to be successful, and then I print enter a color and get the color. So if, oh, I can't believe I forgot this last bit. Sorry, and so I end up with, what should the type of this be? Some person, exactly. So and then I match on that output and I say, oh, this is this some person? Okay, print it. No, I'll print an error. But what problem have I made even worse? Exactly. I don't know where the error comes from at all now. I just know that one happened. So that'll be the next thing that we tackle. So I compiled it to my name. And so what should happen here? Right, it should error. It should, whoa. Oh, right, that'll, yeah. Okay, thanks. Yeah. So we're getting closer. So we're a lot safer now. Our program is less likely to explode, but we've thrown away a lot of the semantics. We don't know when, we don't know where errors are coming from. So to fix that, we're going to actually stop using option and start using either. So either, instead of forcing you to make a choice between something and nothing, forces you to make a choice between something and something that is different than that other thing. So something is either going to be a string or an int. And we're going to say right now that string is an error, like an error string. So this toAge looks almost exactly the same. I parse the I, and then if I do it successfully, I'll package that into a write. And if it's an E, I'll say, okay, this is a left. This is an invalid, with the error message. Same thing for color. I'll do all of these constructors for the right type, and all of these constructors for the left type. Convention says that we use right for correct because it's right, and we use left for incorrect, but there are actually type aliases that that make that a little bit more clear. There's also a type alias of this called try, which works very nicely with Java exceptions, which is great when you're using other libraries. So I'm going to do the same thing here with my for. There's a bit of a bug in the compiler apparently that makes it so I have to type this stuff up here that I won't go into. So I get my age, and now this dot right thing is just making that assumption that I already told you about the right one being the correct one implicit. So you can't map in either. It has to be a right. This is what's called a right projection. Same thing. I get the enter a color, and this is the other side of that same compiler bug where you have to package that into a right, and then same thing for color, and then I yield. So what should the type of output now be? No, it should be an either of, can anyone guess? First one is string. Person, right. So that's a little wonky to see. So let's open up the REPL and take a look. So I have my val I, which I'm going to say is either a string or an int, and I'm going to say this is right of 3. And now I'm going to say I.map x times 2. So any ideas on what's going to happen? So you would think that. Now, the thing is, yeah, you would think that. It might be right. Well, okay, so a lot of people disagree on this a lot. So some people say, oh, implicitly, right should be the correct one, and if you map left, actually, let me ask you another question. Now, what should this be? An error? An error? A 0. Not? son. Right, it's not right because, but notice notice that I2 and I have the exact same type, and I used both. Sorry? It does foobar twice? Maybe. All right. It does not do that. It does not do that. So here's the thing. There's no implicit choice of which answer is correct. So I say, because we're using it for error detection, that I.map x times 2 should keep this error, this foobar error that we're saying. But the library designers disagree with me, so I have to type I.write.map. And it still says, oh, that was the old I. So that does what we want it to do. And then this preserves my error, right? So that's why I have to... Oh, it's just an error. There's no... well, it doesn't compile, which is the goal, because we want incorrect things not to compile, because then we won't run them and they won't blow up spaceships or something. Yeah, exactly. Right. Although realistically, if you're like making a spaceship, Python and Scala are both the wrong choice. Yeah. I don't want to. Yeah, that's the right. Okay. Oh my god. Okay. Right. So this this is this for desugaring, which I would argue at this point it's starting to get a little bit less illegible than if I just used map and flat map, but you know. There are other combinators that work really well with this for syntax. One that works really well is the notion of a future, where if you're calling out to several remote services or web entities, you can say future.map do something, or future.flatmap do another long computation, and those will all get packaged into a future of the final result, which is really nice. But we won't be talking about that because it takes a long time to set up, and demos are hard. So now we're going to write some really unsafe code. So I'm going to take 3 people. So this looks a lot more like C or Java or something like that. So I'm going to initialize my I to 0. I'm going to start my best person as null, which I already told you was the worst. And then I'm going to read a person. I'm going to match on that person. And then I say, okay, if that person was a real person, and if the best is null, or if the best age is less than p.age, I'm going to set my new best person to p. Otherwise, I'm going to... Right, see, when I said that, it was just really hard to understand. And then if it's not a person, I'm just going to print the error. And then I'm going to increment by 1. So let's think about how many possible typos could mess up this program. So if I forgot to do best equals null, what would happen? Wesley. Right, on the first iteration. If I forgot to do I plus 1, it would just loop a million times or forever. And that's why we have the traditional C4 loops, to make that, less likely to happen. So I admit that this might be a bit misleading. Maybe less believable if we fat-fingered this. We'd also run forever, right? So this does work. Oh, and I should say, Does everyone realize what this loop does? It gets the person with the highest age. There it is. Okay. Oh, yeah, if there are comments at the top that say, like, that make all the points, if you guys are, yeah, all right. So I'll compile it, I'll wait for a few minutes, and, um, I might get to that, and so there are these things called implicit parameters, that I didn't include in this talk because they're really wonky, but, you can specify a type for a function and not actually pass that type, and the compiler will look through scope and find it. So it has to look through it has to go up the parse tree and find that type, and it takes forever. But it does allow you to write some neat programs that are correct. So what's my name? It's Lee. I'm 21. My favorite color is red. Someone else wanna? Just Michael. Timbrook is 21. His favorite color is blue. Kristen. See, I need you not to say green this time, though. 23. Oh, no, I do need you to say green. Yeah. Next time, green. The oldest person is Kristen. See? Because, yeah, there you go. So, but that's not very good, right? And this is very, very ugly because, oh, and the one that I forgot is what if all of the people error out? Then I will never get into this branch. Like if all the inputs are incorrect, I'll never get into this branch, and then I'll get to here and best will not be initialized, which is scary. So we'll know exactly what happened if we run this. But if we say like write name to database best.name, and then 3 hours later get name from database print name, boom, right? Yeah. Wait, later. There it is. Okay. Right. So that's my further argument that null is bad. Yes. Yes. So deciding what to call null is, kind of tricky because, you can say that none, the none constructor that we had is the same as null, but it's not because you can't do anything dangerous with it, in my opinion. I don't know. Not what? Interesting. Hmm. Right. And that's I say a good thing. So I don't know if that's the case with Java, but in Scala I don't have to think about that because I just never use null, and it solves a lot of problems. So let's rewrite this in a nicer way. So this iterating through a list of things and this notion of iterating through a list of things and using a kind of champion algorithm, as one professor put it, I don't remember which, is a very common thing to do. We want to find the greatest element in a set, the greatest number in a set, the greatest age in a set of people. I'm blanking, but this is something that happens pretty often, I would say. So the first thing I'm going to do is use this kind of crazy one-liner to get a list of 3 people. So I have 1 to 3 to list, that does what you think it does, and then I map that, and then I do this. So what is this? Any ideas?
So it takes an anonymous thing.
Right. So this underscore means that I'm just throwing this argument away, and then I'm going to read the person, and then I'm going to turn it into a right projection, and then I'm going to turn it into an option. So that's kind of a mouthful, right? And I promise this is not the kind of stuff that you type often. So the reason that you have to turn it into a right and to an option is because I later want to flatten this. So just up until this statement, I'm going to get a list of options. And now, so I might have some 1 followed by none followed by some 3. Now, if I flatten that, remember that options are also lists. I will just have a list of people. Now, you could read that. You could read this line and reason through it, or you could look at this type signature and say, this thing becomes a sequence of people, so obviously that is what it must do. Which, and I mean, maybe not here because we do have some side effect in code that reads people, but it's a lot easier to reason about what complex pieces of code do when you know what the type of the outcome is in a very strong sense, yes.
Is sequence a type you made, or is it a type that you made?
Oh, sorry, sequence is a built-in type.
So is that similar to a set? Like, what's the difference between a sequence and a list?
Sequence is the interface, so it's a little bit more complicated than that because interfaces don't work the same way they do in Java, but suffice it to say you have a map and you have a map method. Yes.
And you use that to keyword there to generate sequences of anything other than numbers.
Probably. So that goes into implicit classes. I don't want to do that right now. Yes.
What would happen if you didn't enter any narrow people here?
You didn't. So then we would have. So then that piece before the flatten, we would have a list of none, none, none dot flatten, and does that make it any more clear? No. Just an empty list. By the way, the reason the REPL is so slow is because it's compiling it on the fly, but once you actually compile it, it's pretty fast. Don't worry about it. It's JVM fast. It's faster than Node.js. Yeah, I said it. Fighting words. It's usually faster than Node.js. It is certainly safer. This is the wrong example. Right, okay, so we have our list of people, and we don't care how this right-hand side works because this type is just so strong that we know exactly what it's doing. And then we say we're defining this max function, this max by function, whose signature looks a little funky. So let's take it apart. I'm defining a function called max by. It takes a type parameter of a, and then its arguments it has 2 arguments. So it has 1 sequences of this type a, and it has 1 function that goes from an instance of a to an int. So if we had a list of people, what would need to be the other argument, the CMP argument? It would be, yeah, what? It would be a function from person to integer, where that would just return the age. If we wanted to sort strings by length, our input would be a sequence of those strings, and the comparator would be, it would be the length function of the string. So what this does is we're going to use our favorite computer science concept, recursion, because loops introduce things like null. And we're going to say, okay, what's our list? If it's nothing, then return nothing, because there's no maximum of an empty list. If it's a single element followed by nothing, obviously, since this is the only element in the list, it must be the greatest. If there's a head of a list and a tail of a list, we're going to get the max of that tail, and if it's smaller than our current thing that we're looking at, return that. Otherwise, don't return the other maximum. So this is, yes, longer than the last thing we wrote, but I can use this max by to get the max of any list for any kind of matching, anything that can be compared. So the main meat of the program says max by. I'm saying, okay, I'm doing this with people. I'm doing this over my list of people, and the method that I want to use is age. And this is just a cool bit of syntax that says call age on whatever my input is. So I could rewrite this as x dot age. Compile it. Yeah, it's exactly what it is.
And CMP can be any function that takes in an element and returns an end.
Right. So yeah, so we'll actually play with changing the CMP function. So Scala C main, I'm going to say Lee. My age is 21. My favorite color is blue. Jesse is 21. His favorite color is red. Kristen. It's time. No, it's not time. Sorry. I know, I'm sorry. 23. Green. It's green. It's green. So, Kristen. So yes, Kristen is the oldest of us, of the three, and it prints her name. So that's fine, right? So let's say I want to I want to find the max by something different. So let me say x.name.length. That might not compile because length might be undefined. So let's see. No, it's, yeah. All right, so man. Also remember that I'm remoted in, so that, could be it, right? So my name is Lee. I am 21. Favorite color is red. Anyone? Timbrook. Oh, that's good because you have a long name. Timbrook is 21. His favorite color is blue. That's what you said last time, right? Brian is 21? 20, whatever. Too late. Doesn't matter. And your favorite color is red, right? I don't know. What, I mean, doesn't really matter. I don't care. All right. So what is it going to return this time? Timbrook, because his name is the longest, and that's our new sorting, champion loop algorithm. So that's great. So what we've done here is turned the notion of control flow into, turned like a control flow pattern into its own function. And we can do this with all sorts of things. So turns out this already exists because it's a very common thing to do. I disagree with the Scala standard library here because maxby does not return an option. So if something is empty, it will either blow up or return null. It'll probably blow up. So that's actually all I had for this example. That's actually all I have completely. I had another example that is not quite done, but it uses fold left, which is another kind of reification of control flow. I really encourage you to, try this out. Look through some of your code in Python or Java or Ruby or what have you, and look for combinations of configurations of whiles and ifs and fors, and I think you'll find that you can turn a lot of them into these kinds of functions. And yeah, that's all I have. If I can do implicits if anyone's interested. They're pretty zesty. Yeah. But yeah, everyone looks pretty not. Does Scala have currying? Excellent question. So, is everyone? So I'll first explain the notion of currying. So, you know what? Let's not do this in Scala. So this is this is Haskell. So all right. So in Haskell, functions don't take several arguments. Functions return arguments. A function of multiple arguments will return another function with one fewer argument. So if I want to say add x and y, I'm going to say x plus y. Do you guys see why I didn't do this in Haskell? All right, so did it work? Okay, all right. So what's the type of this function? Oh, damn. All right. All right, you know what? Okay, it's still that. Don't even think about that yet. So in Java, this would say, okay, the parameters are an integer and the result is an integer or a double or whatever. Now, the type of this function is from integer. It takes an integer and it hands back a function from integer to integer. And then you take that function and you pass in an integer. So I say add 4, 5, and it does it, right? And now I say add 4. Ooh. I tried to print something that can't be printed. And now I have a new function. And now this function is from int to int. It only takes one int because it saves the 4. So I can say add 4, 6, 10, right? So if you look at the type, yes. So yeah, no, it's exactly the same, but it's done automatically, and that's very helpful sometimes. Let's say that you wanted to. Well, okay, so Haskell does some even other stuff that. Yeah, it does some stuff. So like, let's say that. Yeah. So like, let's say that this was like some insanely. Let's say that was insanely, just something insanely complicated and takes forever. So you can say that, let's say that 6 takes forever to compute. So we can do this, and then all the work done to compute the 6 is saved, and then you can just add 6 to whatever you want without recomputing it. So, sorry? Yeah, that's lazy evaluate. It'll only be evaluated once. So, all right. So the thing about Scala is that the evaluation is right, but the syntax is very useful. It's very conducive to doing things in this functional way where we. Here, I'll do an example. So. 6. Okay. So I have my max by, right? And now I have this max by function. It's pretty useful, but whenever I use it, I need to associate the actual list that I'm iterating over with the function that I'm using to get the maximum. So maybe I just want to define a function that gets the biggest age of the person, because it's the name is better. So I can say get person with max age, and now I can partially apply this function, which is technically different than currying. And then I can say this is of type sequence of A, and this is so. What do you guys think the type of this function will be? Anyone? Close. The same type as what? Sort of. So, I mean, it's not fair. You already know Scala. I think. I know. Yeah. Oh, it's fantastic. There it is. It did. Okay, so um, what I'm doing here is I'm saving the second parameter. I'm saying, okay, whenever you use this function, use this underscore dot age lambda that I'm creating. And now, whenever I use max by on a sequence of people where I want the biggest the person with the largest age, I don't have to go through the mental acrobatics of using max by. I can just say get person with max age. But I've gotten all this control flow for free, because all I'm saying is that I'm using this iterative pattern with the age. I can also do get person with max with longest name, and I won't do the type signature because it's long. And I think I can actually leave out the type of that as well. And I can say name.length. So I actually will annotate this because that line is confusing, and I want to hint with the type. Yes. Usually the rule is if there's a recursive element to it, it can't figure it out. Yes. Immutability in Scala is complicated. There are a lot of traditional topics that are used for functional programming talks that I inherently stayed away from because they're complicated. So the one thing that we saw immediately was I say val scan, and so you would think that this scanner is immutable, right? Because it's a value, and we saw earlier in I think 5 that if I use var, I can change the value of things, but if I use val, I cannot. But I am mutating the scanner. I'm like moving the output buffer. So this ends up being a mutable reference, but not a mutable object.